Hello and welcome to Vase Projects. We are continuing with going over the designs. Today we're going to be doing the design of Link 2. And I'm not as excited for this design. It's not as simple. I can't tell if it's stupid or genius. And we're not going to know until we make it and it breaks. So let's go to the board. It may seem like there's not a lot going on here, but this is actually my solution to a very complicated problem. But let's go from the top. Design things we need to solve. It needs to connect to Link 1. Boom. We got a male connection. Male connects to female. Easy. 2. It needs to have powered shaft connection. D profile. Put the shaft through the D. There you go. Connection. It's solved. Easy. No issues at all. And then the third is that it needs to have a wrist. And I don't know if you guys have ever heard of a wrist before, but they're not the most basic things in the world. They do a lot. And they're kind of complicated. Doing this, yeah, that's easy. Doing this, yeah, easy. Doing this, not so easy. And that's complicated on like a biological level. Imagine doing that mechanically. It causes problems, and there's lots of solutions. You could do multiple bevel connections. You could do a lead carriage on a lead screw. You can do a powered ball socket. You can do lots of things. But all those are very complicated solutions to a complicated problem. And I'm not over here curing cancer with this thing. I just needed to wield a knife, and wielding a knife isn't that hard. You just gotta do this, right? So let's simplify the wrist. That's what I'm thinking to myself when I came up with this 2 a.m. on a Tuesday. So we got everything, we got this squared away. This is perfect. That's never gonna have any issues at all. So now we have this. How I'm gonna solve the wrist. How I'm gonna put the wrist on Link 2. Well, I'm gonna put a hole in Link 2. There's gonna be a hole in it. And you gotta put the motor in the hole. And so the motor shaft is sticking out this way. And so it rotates this way around, allowing for this connection essentially on the wrist. Easy. We're halfway there. We still need to do like a bunch of other things, but that's enough, right? And we need to solve the other connection of the angle of when to wield it, because if you have it straight out and you swing it this way, it won't be able to cut butter. It needs to be flat, perpendicular with the butter to cut the butter. And so it can't just be straight up and down. It needs to be at an offset angle of phi. And if we put that offset angle of phi, we won't have to actuate this way. We can just offset it here where it needs to be, and then rotate back and forth, and that'll be all we need. So we put a hole in the thing, and then we offset everything by phi. And then that'll give us a wrist with quotation marks. And that'll solve that problem. And it won't ever have any issues at all. And then lastly, for this design, we need dimensions. I didn't put any dimensions on here. You might be thinking, well, that's because you made up all the other numbers last time. You're wrong. It's because the dimensions here are kind of weird. With the offset effector, this whole link doesn't really matter. What really matters is the end of the motor and where that connects. So the distance from this connection to the end of the motor connection is going to be 3 inches. And you might be thinking, well, where'd you get that 3? I made it up, but that's not important. What's important is that this is going to work and this is going to work. That's what's important. And then this can be 3D printed. So in conclusion, this will work and I'm a genius. Next week we'll go over the effector, what I have for the effector design, the thing that holds the knife. That's not great. I'm looking forward to it.